All right, Matthew, we got the last lesson for the week here. We got lesson 1-A, word problems. So we're going to just do algebraic word problems we're actually going to be solving. So a little bit different from the last lesson where we were just writing expressions. Now we're going to get some equal signs on those. So when we're doing word problems, we're going to just kind of follow these steps. We're going to decide what our variable is. Usually it's what we're looking for. So are we looking for how many days something happened? So that's going to be our variable if that's what we're looking for. Or how much money we have, the money would be our variable because that's what we're looking for. Once we've decided what our variable is, we're going to create an equation, so we need an equal sign, with the variable in it. Once we have the equation with the variable in it, we're going to solve that equation. Then we're going to answer the question. Now that sounds weird because I just said we solved the equation. Why do we need to answer the question? Well, sometimes the answer to the variable isn't actually what you were looking for the whole time. You might use the variable to find what you're looking for. So we're going to make sure that we're answering the actual question in the problem and not just solving an equation. The last thing you're going to do is to just make sure that your answer makes sense. There used to be this test that we would give out, I don't know, this was several years ago, but there was always a problem where there was like a cheetah that was running. And I can't tell you how many students solved that problem and told me that the cheetah was going like 10,000 miles an hour. That makes no sense. That just means you're writing down random stuff and not even thinking about what you're writing. So make sure that your answers make sense for the problem. Does this sound reasonable? That should be a question that you ask yourself constantly. Don't just do some math and then just put down whatever number that you think is the answer. Make sure the number makes sense. I'm not going to give you a cheetah that's going faster than the speed of sound. All right, so here we go. We're going to define our variable here. 15 less than twice the number is 37. Find the value of the number. I'm looking for the number. So that needs to be my variable. I'm going to define that variable. Let's call the number n. So I'm going to say the number is going to be n. That's the number that I want. So that's my variable. All right, now I'm going to make an equation. Now this is very similar to our last lesson. We've got 5 less than. Remember, that meant we would switch the order. So I'm going to switch negative 15. I'm going to put that at the back. And I'm going to put twice a number at the front. Twice a number means 2n. So we got 15 less, minus 15, than, the 15 goes at the end. Twice a number comes first. Is means equals. So equals 37. I now have an equation for solving. So I'm going to do step 3. I'm going to solve that equation. I'm going to start by adding 15 to both sides. We get 2n. Ooh, I forgot the line. Ooh, almost wasn't a good person. 37 plus 15 is, I don't know, 52. Then we're going to divide by 2. Ran out of room. Poor planning. And I get n is equal to 52 divided by 2. That's 26. Find the value of the number. The number is 26. I'm answering the question. Why didn't I just leave it as n equals 26? They didn't ask me what n is. They asked me what the number is. So I'm answering them. They didn't know that I made n the variable for the number. So when they say find the value of the number, I have to tell them, oh, that number is 26. There you go. I answered it. Does this make sense? Yeah, I'm not getting anything crazy here. So yeah, it kind of makes sense to me. Next problem. Angus went on a 2-day hiking trip and traveled a total of 32 kilometers. On the second day of hiking, he traveled 4 fewer kilometers than the first day. How many kilometers did he travel on the second day? All right, now this one's a little bit different than that previous one. When I define my variables, I've actually got two things that I don't know on this one. I don't know how much he hiked on the first day, and I also don't know how much he hiked on the second day. So I need variables for both of those. So I need to know the first day's distance and the second day distance. Now they both can't be the variable. So on this one, here's how I decide which one is going to be X or N or D or whatever letter I use. I look at it and ask, okay, what is being compared to the other thing? Well, I can tell here the second day is being compared to the first day. So that's telling me I need the first day to be my variable because the second day is being compared to that day. So I'm just going to call it H for hiking. Sure, why not? So I'm going to make the first day H because the second day is being compared to that day. Now, I'm not going to come up with a different variable for the second day because that would be too hard to solve it if I have two completely different variables. So here's what I'm going to do. The second day, this one, he traveled 4 fewer kilometers than, oh, that's a big word. So it says 4 fewer. So that means I'm going to have -4 at the end because of the than. 4 fewer than what? 4 fewer than the first day. Oh, the first day, what did we call that? We called that H. Sorry, that got a little crooked on me. Got a little excited there. So we get H -4. So this is 4 fewer than the first day. So now I have my two variables. Well, not two variables, my two unknowns. I don't know the first day's distance. I don't know the second day's distance. I do know there's a relationship. The second day is based off of the first day. Now, in the 2 days, do I know how far they traveled? Yes, I know they traveled a total. Total means equal. So my equal sign is going to be for 32. I've defined my variables. I'm creating an equation now. Total, 32. So equals 32. What equals 32? The 2 days of hiking. So day 1 is H plus the second day, which is H -4. All right, there we go. So we are going to combine our like terms. We get 2H -4 equals 32. That looks like an N, not an H. There we go, better. All right, we're going to use our addition property of equality. Get add 4 to both sides. We get 2H equals 36. Okay, divide by 2. We get H equals 18. Now we're going to answer the question in the word problem. How many kilometers did he travel on the second day? Is it 18? Nope. H is the first day. So that's why we define our variables, because now we can go back and go, oh, for the second day, I'm supposed to do 18 -4. So the second day is 18 -4. Looks like he traveled 14 days on that day. 14 kilometers on that day. So now I can answer the question. He traveled 14 kilometers on the second day. Last step, let's make sure this makes sense. Okay, we're saying the first day he traveled 18, the second day he traveled 14. Does that equal 32? It should. Let's see, 18 plus 14. Yep, that's 32. So everything's looking right. I've checked to make sure my answer makes sense. I've answered the question. I didn't just solve it. I answered the question, and then I checked to see if it made sense, and it does. So everything is right and good in the world. We can move on to number 3. 4 friends have collected 67 shells at the beach. Sounds like a good day. Martha collected 2 more than Thor, the god of thunder. Helen collected triple the amount of Thor. Wilhelm collected 5 less than twice the amount of Thor. So Wilhelm collected 5 less than twice the amount of Thor. How many shells did each friend collect? Well, I've got 4 friends here. So what were their names? We had Martha. We had Thor. We had, who else? Helen. And we had Wilhelm, or Wilhelm. And these are representing how many shells each of them had. Okay, I can't make them all variables, because if I had M, T, H, and W as variables, that's not going to be able to be solved. So I have to pick one of them to be my X value for my shells. Let's see. Martha is compared to Thor. Okay, so Martha can't be X because she's compared to Thor. Helen is compared to Thor, so Helen can't be X. Wilhelm is compared to Thor. It looks like Thor has to be X because everybody else is being compared to him. So let's make Thor X. Okay, let's go up here. Martha is 2 more than Thor. All right, so we got a than there. So Martha is 2 more plus 2. The than means plus 2 goes at the end. Thor, we just said that Thor was X, so we can call that X plus 2. So this means Thor plus 2. Next sentence. Helen collected triple the amount that Thor did. So Helen must be 3 times Thor. Thor is X, so Helen is 3X. And then we've got Wilhelm. Wilhelm collected 5 less than, so we've got 5 less, so that's minus 5 at the end. Than means I'm putting it at the end. What should I put in front of it? Twice Thor, and Thor is X, so 2X goes here. All right, I've got the 4 friends. Here it says 4 friends have collected 67 shells. Have a lot of times can be the equal sign. So this is a total. So everything's going to be equal to 67. Now what would equal 67 shells? Well, it would be Martha's shells plus Thor's shells plus Helen's shells plus Wilhelm's shells. That's a lot of S's. So we're going to just write this plus this plus this plus this. So we got Martha. We've got Thor, X. We got Helen, 3X. And then we got Wilhelm. Ooh, I'm running out of room. This was poor planning. All right, there everybody is. Okay, I should start this one by combining like terms. There's no distributing, so we combine the like terms. We got X's all over the place. I've got 1, 2, 3, 4, 5, 6, 7 X's. Okay. And then I also have like terms with my 2 constants here. I've got 2 minus 5. That would be negative 3. Equals 67. Finish solving it. Add 3 to both sides. (7x) equals 70. Divide by 7 on both sides. And we get x is 10. Is my answer 10? Kind of, not quite. I have to find out how many shells did each friend collect. So I just got done solving the equation. Now I have to answer that question. How many did each collect? So Martha, she collected 10, because that's what x is, plus 2. So Martha collected 12. Thor, he collected 10, because he was x, x is 10. Helen, she did 3 times x. That's 3 times 10. Helen is 30. Wilhelm, we do 2 times 10. That's 20. 20 minus 5 is 15. Yeah. Wilhelm is 15. Now we're going to make sure that the answer makes sense. Do these add up to 67? 12 plus 10 is 22. 22 plus 30 is 52. 52 plus 15, yep, that's 67. So I think this makes sense. Last one. All right, the perimeter of a rectangular garden is 150 feet. Let's draw a picture here. So here we've got a rectangular garden. There's like plants in there, some bushes. Oh, they got some fruit on it. Yay. Okay, so we got all this stuff in the garden. Yay. The perimeter is going all the way around. So the perimeter has 4 different sides on it, right? So we're going all the way around this object here. So if I add up those 4 sides, it's saying that it should add up to 100 feet if I go all the way around. All right? It says the length is 4 less than twice the width. Find the length and the width of the garden. Okay, so I need to find 2 things. I need to find the length of the garden, and I need to find the width of the garden. They can't both be a variable, so I have to decide which one is my variable. Well, length is being compared to width, so width needs to be my variable. I'll call it W for width. All right, so the length is 4 less than. Okay, so than means I'm going to do 4 less at the end. So this goes at the end, 4 less. And what should go at the beginning? Twice the width should go at the beginning. So 2 times the width. And we said the width was W. So we would get 2W right here. All right, now it's time to write an equation, but we have to be careful. A lot of people would go, oh, I just add these 2 together. 2W minus 4 plus W equals 100, and I've got my perimeter. Wait a second. Making a drawing is important because I know that this is W here, and then this would be 2W minus 4. That's not the perimeter. That's only halfway around. I still need to go over here and over here. So in the perimeter, there's 2 widths and there's 2 lengths. So our formula for this one, when we write an equation, we're going to have 2 of the width plus 2 of the length. That's what's going to equal 100 feet total. So our perimeter has to go all the way around. So I'm going to have a width here and a width here, a length here and a length here. All right, we can distribute these. Draw a line down there because we're good people. So 2 times W, 2W. So bad. Plus 2 times 2W, that would be 4W. And then 2 times negative 4 would be negative 8. Okay, at this point we would combine our like terms. We'd get 6W minus 8. We would add 8 to both sides. We get 6W is equal to 108. And lastly, I would divide by 6. Let's see. 6 goes into 10 once with 4 left over. 6 goes into 48 8 times. So 18 is our width. We have now solved the equation. Did we answer the question? No. The question says, find the length and the width. We only found the width. So we can say that the width of the garden is 18. The length of the garden would be 2 times 18 minus 4. So for the length, I can't spell. The length, we have to do 2 times 18 minus 4. So that would be 36 minus 4, 32. So my length of the garden is 32. Now let's see if this answer makes sense. If this makes sense, our length and our width should add up to 100. So let's see. So we've got 18 here, 18 here, 32 here, 32 here. Let's see, 18 plus 32, that is 50. And then this 18 plus 32 is 50. So yeah, if I add all 4 of these together, I get 50 plus 50, which is 100. So my answer makes sense. And now I can end the problem. And that means we're done. All right, Math Hard. See you guys later. Bye-bye.